Hi. Sometimes I want to be able to find my way around a file quite quickly. I'm looking for errors in a file. I know there might be an error in there somewhere, but I don't know where. Or I might want to check to see if a range of cells is being used somewhere in the file before I try to delete it. I don't want to delete something and then find I need to put it back in, especially if it's a worksheet. Because once you delete it, you can't just put it back in again. You have to have saved your file first, then delete it, so that you can recover the old version. So we have, on our formulas menu, we have trace precedents and trace dependents, which can be helpful to find out, to understand our way around things, but we can do one at a time. We can only do one item at a time, and it's not really very practical. So what I did a long time ago, one of the first pieces of code I ever wrote, was wrote a piece of code that loops through all my cells and uses the trace precedents and trace dependents features. It takes a moment for the graphic to be created, and we'll catch up with it in a minute. There's my audit on this range of cells, and straight away you can see there's something wrong with it. This section is all very neat and wonderful and all nice straight lines and working correctly, and now we can see immediately without any effort whatsoever that this section is not being used properly and this section is going in the wrong direction. So clearly what's happened here, we've got a sum of each set of rows, but at some point our sum has become misaligned with the data. And this one, well, it's an example file, so I cheated and just typed a number in there. But this is an example of something that does happen in real files. And this piece of code will help you to find where things like this has happened. And again, I can use it on here. I can see there are no links across to another worksheet. Okay, there's only one worksheet in this file, but if there were, then we would see the additional arrow pop up to say it's being used somewhere else. This code comes with some caveats. It's not perfect. There are a few problems you can get when using this code, so we'll come to that in a minute. First of all, the simple version. I am declaring a range, a cell. I am looping through every cell in my selection, and I am showing dependents, and that's it. I'm just showing all the dependents from that cell to anywhere else. And I can use show precedents instead if I want to go the other way. This example is looking at dependents. Sometimes you want to be able to just draw a map of what information has come from where, just to help you visualize what's happening on the sheet. But there are some problems with this piece of code. So I've created a larger version that has lots of error handling in it. I didn't want the error handling to get in the way of showing what the simple rule is. First of all, screen updating. I don't normally like to switch screen updating off and then back on again. This is one of those times where I will. Otherwise, you just see all the arrows being created, and every time it creates an arrow, it will try to reset the screen, and it becomes very slow and cumbersome very quickly. These arrows are quite memory hungry. They slow the machine down. Excel does not like these arrows, which is the big problem with this particular piece of code. That's why we have this error handling. So I switch off my screen updating for that reason. Rather than just allow every cell in my selection like I did before, I'm using the intersect of the selection and the sheet's used range. If I click there, I am allowing, what, 1 billion plus cells to potentially be tested. And the loop alone will take plenty of time, even without actually doing anything. So I limit it to just the use range of the worksheet. The next thing I want to do is I want to check that I'm not about to kill Excel by trying to run this code where there are many dependents. You know, it's like sometimes you click trace dependents and it turns out you've got 1,000,001 sum if formulas that are looking at the whole set of data, and you just get this blue blob of lines appear. We definitely can't have that in this code, because if it does it once, it's going to do it on every single cell in our selection. And I've learned this the hard way. I've had Excel hang up on me to the point I've had to Control-Alt-Delete kill it, just to stop the code running. So I count how many dependents there are, so that I can then decide whether or not I want to take the next step. I stick an on-arrow resume next around it, in case there are no dependents, because the code would fall over. It would say it doesn't exist. So if I have a large quantity of dependents, and I've set the number to an arbitrary 50, that works for me. If that happens, I will throw a message box at myself saying, are you sure you want to continue with this? And if I decide at that point, no, I don't want to, I've done a bad thing, then I will simply terminate the code, which all it does is jump to the end and switch screen updating back on. If there are no such problems, it will continue through every cell in the range and show dependents, like the simpler version did. And then right at the end, it will switch screen updating back on. And that is my piece of code. Take care using it. Like I say, we have to make sure we have these tests in place to make sure we don't kill the machine. Don't try and do it on too large a range, because even if you've only got 40 dependents in for every cell, if you run it on 1,000,000 cells, you're going to cause yourself problems. Use it carefully, but it can be very useful. Okay, good luck. And if you want a copy of this file for download, I'll make it available. I'll post the link below so that you can find the downloads that support my videos. Okay, thanks for watching.